Sport-specific prosthetics are difficult to produce, and few allow individuals to excel at their given sport. In this project, we created a prototype basketball prosthetic hand allowing for a more natural basketball shot with finer control. This project was made possible through multi-material 3D printing and 3D printed springs. In the final prototype, you can see there are both coil and cantilever springs that allow for the energy storage and return functionality. The coil springs represent the force generated from wrist flexion, and the cantilever springs can flex independently and represent the force generated from finger flexion, which is crucial to generate backspin during the shot. The coil springs were printed from a conductive PLA filament and act as integrated strain sensors. This strain can be mapped to proportionate haptic feedback, leading to greater control for the user. 2 haptic motors will be positioned on the user's residual limb, and they can guide the user if they are shooting off track. The prosthetic was designed to fit the standard 1/2-inch diameter threaded stud on upper extremity sockets. To test the feasibility of this system from an able-bodied user, an adapter was made by attaching the prosthetic to a wrist brace. Here, we can see the movement during a traditional shot. As upwards velocity is generated, the ball rolls deeper into the fingertips, and then both wrist and finger flexion occur simultaneously as the ball is released. Now, we can look at what a full shot with the prosthetic looks like. Breaking the shot down, you can first see the coil springs begin to compress as upwards velocity is generated. Next, the ball rolls deeper into the fingertips as the cantilever springs flex back. Lastly, you can see the coil springs fully extended after they had transferred their energy to the ball and the cantilever springs are returned to their original position, all leading to a more natural basketball shot. Here's the full shot again. Testing the prosthetic on an actual hoop, we were able to achieve a very natural shot. We hope the concepts in this prototype will be applied to other sports, leading to prosthetics that allow for more natural motion and increased capabilities.